All right, let's take a look at SparkSQL in action, get down to the nitty-gritty of how it actually works. So I've gone ahead and imported the sparksql.scala file from the course materials into my project. You've seen me do that enough times. I don't think I have to go through the details again. So go ahead and pause and continue when you've got that up and running here. And let's take a little look. So we've imported the spark.sql package here into our driver script along with everything else. And what we're going to do is load up that old fake friends.csv data that we used earlier in the course. And instead of actually analyzing that using RDD functions, we're going to analyze it using SQL. So we're going to convert that to a structured format into a data set that we can actually issue SQL commands on. Pretty neat stuff. So the first thing we're going to do is set up a Spark session object. And this is different than we've set things up before. Usually we've used Spark contexts, but by using a Spark session, we get back an object that we can actually do SQL commands on and actually deal with data sets instead of RDDs. So the syntax here is we're going to create a Spark session using a builder method, specify the app name, master of local on every core like we usually do. This next line is specific to Windows. There's actually a bug, unfortunately, in Spark 2.0.0 where you have to explicitly set a directory for temporary data on SparkSQL on Windows. So if you're not on Windows, leave that line off, comment it out, okay? But if you are on Windows, you won't be able to run without it. Go make sure you do have a C temp folder on your hard drive first. If you don't, go ahead and create that right now, please. And finally, we'll call get or create to actually create our Spark session or get an existing one if we're recovering from a failure. So that's kind of cool. You know, if we actually have some sort of a problem that comes up, it can automatically recover from where we left off using get or create. Next thing we're going to do is actually load up our data here. And since our data is unstructured, it's just a CSV file, we have to first structure that before we can actually convert it into a data set. Now, if we did have structured data, let's say that our friend's data was in an actual database or in a JSON file, for example, we could load that up directly and actually create a data set out of it right away. For example, we could say spark.read.json given a JSON file name, and that will give us back an actual data set as opposed to just an RDD. But since our data is unstructured, we have to first impart structure upon it before we can do data set stuff with it. So we'll do that with this mapper function. And all this does, if we go up here, it maps every input line of that RDD to a person object. So that person object is defined by this case class here. And case class, again, is a Scala construct for basically creating a very simple class that has accessors built into it and constructors built in for it. It's a little bit magical because the names of all these parameters actually map to actual column names in the data. So by mapping our string into these person objects, we end up with named columns in our resulting RDD. So we know that we have an integer that is named ID as one column. We have a string with the name of name as another column. We have an age integer column, and then we have a numFriends integer column. Okay, so by calling this mapper that creates person objects based on the comma delimited values that we extract, we end up with this structured data that we can then create a data set out of. Now a little bit of voodoo here. You have to do this import spark.implicits._ line in order for Spark to be able to convert a structured RDD into a data set. So anytime where we're actually going to be inferring the schema of something, we need to make sure that we're importing spark.implicits. Otherwise, you'll see these weird cryptic errors, and you'll wonder what the heck is going on. But if you're ever in a situation where you're calling .2ds and it just doesn't compile and you know it should, you're probably forgetting this line here. But with that in place, we can do this. And take a look. Schema people here actually ends up being a data set of person objects. So here we finally have an actual data set. And the beauty of that, again, is that we can actually treat it just like a SQL database. And what's even more beautiful is that Spark has special optimization logic for things like this, where it can actually do a better job of optimizing your task on a cluster. So at this point, let's print out the schema, take a look at what it actually inferred it to be. And now things get really interesting. We can call create or replace temp view to actually convert the contents of this data set into what looks like a SQL table, and that table name will be people in this example. So at this point, we basically have a little SQL database sitting in memory inside of Spark, distributed, potentially on a cluster that could be huge. And we're just going to refer to it like we would any other SQL database under a table name called people. And check this out. We can now create a data frame of results by just calling spark.sql. Remember, Spark is our Spark session object that we created up here. And we can call .SQL with plain old SQL, like any old SQL you can dream up, including user-defined functions, anything. Huh? So we're going to say select star from people, where people is what we created our temporary view, our little table from schema people, where age is greater than or equal to 13 and age is less than or equal to 19. So what we're going to get back is the results of this SQL query, which will be a data frame of all the teenagers in our input data from that data set. Pretty neat. We'll collect the results and print them out. So let's, and then when we're done, remember to call stop on the session object. You should think about this just the same way as opening up a database connection in any other language and stopping it when you're done. So let's go ahead and run that. I already created a run configuration for it. If you need to do so, please go and set one up that looks like this. Project, given your project name, and the main class should be com.sun.software.spark.sparksql, just like that. And let's go ahead and run it and see if it works. And sure enough, it did. Pretty cool stuff. So here's that part where we said print schema, and you can see here that it's actually outputting how it converted that RDD into a data set. And that data set structure has ID, name, age, and num-frames of given types: integer, string, integer, and integer. So Spark is going to use that information to send information around in the most compact manner possible, and also optimize that SQL query as well as it can as well. And that SQL query that we ran gives us back all of the people that are teenagers in our data set. So these are all, remember, user IDs, names, ages, and number of friends. All these ages should be between 13 and 19, and sure enough, they are. It worked. Pretty cool stuff. So that is SparkSQL in a nutshell. But there's more than one way to do it. So in our next lecture, let's show how we can do the same thing without actually incurring the cost of parsing actual SQL commands. We'll do that next.